rates. Related rates is an abbreviation. It's short for, does anyone know?
Related rates of
Yeah, yes, this is right.
change.
Which was a really bad thing for me, excuse me, in my grade, because our unit of studying English was change, rather than like journeys or something like that. So it was bad jokes a lot of the time. So therefore, to understand related rates, right, we really need first to make sure we understand what are rates of change, which we did last year. Okay, so let me try and remind you. What was the big idea behind rates of change? It was that we've learned all of this differentiation and integration business, okay, but for a long time it was very abstract. It was just letters, variables. We didn't know what any of them meant. And in fact, most of the time, none of them really meant anything. They were just letters that followed values that followed certain rules, and they didn't really refer to anything in real life. Okay? So the idea behind rates of change is that these two things, these values, these variables, y and x, are actual things. Things you can really measure, like say a population and a time, right? And so a rate of change is, how does a population change as time changes, okay? We looked at all kinds of different examples of things that can change over time, okay? So that was rates of change. So what's related rates? The idea is that you can have multiple kinds of rates like this, okay, which you can think of separately, but you can also think of as related to each other in this way. Example. Let's think of, say, a person, and at least, you know, at your age, from age, 0 up to, well, I think this is how everyone stands, isn't it? Up to whatever, 18 or 21, or maybe for you, sadly, like 16, people grow, right? So your height is a variable and it changes over time. Okay? So you can consider the rate of change of your height, that's the change in height, over the change in time. Okay? So see how your height is changing. And I guess, if I had to guess, it'd be sort of like a log curve, right? It sort of starts off really steep and then it gets more gentle. Okay? But by the same token, it's not just your height that changes, right? It's also your weight that changes, yes? Right? So, did I go too far? I'm not referring to anyone specifically. Am I, Jeffrey? Anyway, so weight is a whole different variable here, right? I don't want to go crossways because actually it's not width, right? But weight, I can consider that over time as well, right? Now here are two rates, and clearly they are related. Okay? Clearly there's some kind of connection here. Okay? Now it's not just by experience, as something gets taller, you hope it's getting heavier, right? Or vice versa. But you can see mathematically, the relationship is, well, it's actually written there, isn't it? What's the thing that connects these two? It's time. Because there's a common variable between the two of them, okay? We can actually, if we wanted the relationship between height and weight more directly, without this intermediary variable in between, you'd say, well, let's see, how does height change as weight changes? How do these two relate to each other? You'd say, I can work that out by taking this rate of change and multiplying it by this one. Sorry, wrong way. Okay, now admittedly this is not that, it's the reciprocal of that, but if you know what the weight change is, you can work out what its reciprocal is. Okay. So the key idea for related rates of change is not just that these things actually stand for values, right? But this, see, you learnt this has a name. This is called the chain rule, right? So the idea of related rates is that chain rule isn't just some fancy mathematical operation that helps you differentiate and integrate stuff, right? That's nice, okay? Chain rule means that there are different rates and they're related to each other, and you can come up with their relationship if you put them together in the right way, okay?